Use part 1 of the fundamental theorem of calculus to find the derivative of the function. Let's start with example 1. Suppose we're given g of x is equal to the integral from 1 to x of natural log of 1 plus t squared dt. And I want g prime of x. To find g prime of x, I'm going to do the following. In the integrand natural log of 1 plus t squared, I'm going to replace t with x. And so g prime of x is equal to natural log of 1 plus x squared. And that's example 1. Let's take a look at example 2. Suppose g of s is equal to the integral from 0 up to s of t minus t squared raised to the 8th power dt. And I want g prime of s. So in the integrand t minus t squared to the 8th, I'm going to replace t with s. And so g prime of s is s minus s squared raised to the 8th power. I'm done. Let's take a look at example 3. Suppose h of u is equal to the integral from 0 up to u of the square root of t divided by t plus 1 dt. And I want h prime of u. Well, in the integrand square root of t over t plus 1, we replace t with u. And so we get the square root of u divided by u plus 1. Let's take a look at example 4. Suppose f of x is the integral from x up to 0 of the square root of 1 plus secant of t dt. Now, notice how the lower limit ended up being the variable. In example 3, example 2, example 1, notice how the upper limit is the variable. In order for us to take the derivative, we have to have the upper limit be the variable. So how do we do that, or how do we deal with that? So what I'm going to do is I'm going to switch the lower limit and the upper limit. And so in other words, I'm going to take the integral from 0 to x of the square root of 1 plus secant of t dt. But I can't just switch those limits without offsetting this integral with a negative. So in other words, I'm going to multiply this integral by a negative 1. And when I do that, I can switch those limits. So notice how my variable limit is the upper limit. And so when I take the derivative, when I find f prime of x, I'm going to replace t with x in that integrand. But I got to carry the negative down. So the answer here is negative the square root of 1 plus secant x. And that's how we do example 4. Let's take a look at example 5. Suppose r of y is the integral from y up to 2 of t to the 3rd sine of t dt. And I'm basically going to do the same thing as I did in example 4. I'm going to swap places. And so this ends up being negative the integral. So the limits have to swap places specifically. So this is negative the integral from 2 up to y of t to the 3rd sine t dt. And I want r prime of y. So in the integrand t cubed sine of t, I'm going to replace t with y. And so this is negative y cubed sine of y. I'm done. Let's take a look at example 6. Suppose h of x is the integral from 1 up to e to the x of natural log of t dt. Okay, so if you look at example 5, notice how the upper limit here ended up being y. In example 4, the upper limit here ended up being x. Well, in this problem, the upper limit is not x, it's e to the x. So when we take the derivative, we're going to have to apply the chain rule. So how do I do that? In the integrand natural log of t, I'm going to replace t with, instead of x, it's e to the x. But by the chain rule, I have to multiply by the derivative of e to the x with respect to x. So in other words, I'm going to multiply by the derivative of that upper limit. Now, this says h prime of x is x times the derivative of e to the x with respect to x is e to the x. And again, natural log of e to the x ends up being just x. So that's h prime of x. So it's a direct application of the chain rule. Let's take a look at example 7. Suppose y equals the integral from 0 to x to the 4th, doesn't matter, of cosine squared theta d theta. And I want y prime. So remember, you're taking the derivative of y with respect to x. And so I'm going to replace theta with x to the 4th. So you get cosine squared of x to the 4th. But by the chain rule, I have to multiply by the derivative of x to the 4th with respect to x. And so therefore, y prime is 4x cubed, right? That's the derivative of x to the 4th with respect to x, times cosine squared of x to the 4th. That's example 7. Let's take a look at example 8. Suppose y equals the integral from sine of x up to 1 of the square root of 1 plus t squared dt. And I want y prime. Well, before we do that, we have to make sure that this sine of x is an upper limit and not a lower limit. And so I have to rewrite this integral as follows. This is going to be negative the integral from 1 to sine of x of the square root of 1 plus t squared dt. And so in the integrand square root of 1 plus t squared, I'm going to replace t with sine of x. So this is negative the square root of 1 plus sine squared x. But by the chain rule, I'm going to multiply by the derivative of sine of x with respect to x. And so here, this is negative cosine of x times the square root of 1 plus sine squared x. So again, this is y prime. And that's example 8. This is a really good question. So let's take a look at example 9. I'm going to ask you the following. Suppose capital F of x is the integral, we're going to go from x to x squared of e to the t squared dt. This is an outstanding question, and if I'm your Calculus 1 teacher, I wouldn't be shy to ask you a question like this. Now, what I'm going to do is I'm going to break this integral up, and I'm just going to choose an arbitrary number, let's say 1. So this is the integral from x to 1 of e to the t squared dt plus the integral from 1 to x squared of e to the t squared dt. Now, remember, this lower limit of x must be an upper limit for us to be able to take the derivative of that one term. So, therefore, f of x is negative the integral from 1 to x of e to the t squared dt plus the integral from 1 to x squared of e to the t squared dt. This is an awesome question. So f prime of x is, now I'm going to take the derivative of each term individually. So in the first term, I'm going to replace t with x in that integrand. And so this is negative e to the x squared plus, now I'm going to replace t with x squared to take the derivative of the second term. So this is e to the x squared squared. But by the chain rule, I have to multiply by the derivative of x squared with respect to x. And if I simplify, this is negative e to the x squared plus e raised to the x to the fourth times 2x. So again, this is f prime of x. Number 9 is a great question. So, yeah. All right. Let's do one more for this video. We'll call this example 10. And suppose I ask you the following. Doesn't matter, because the process is very similar. Suppose we have the integral from cosine of x to sine of x of natural log of 1 plus 2v dv. And so this is the integral from cosine of x to 1 of natural log of 1 plus 2v dv plus the integral from 1 to sine of x of natural log of 1 plus 2v dv. And so I have to fix the first term. So this is negative the integral from 1 to cosine of x of natural log of 1 plus 2v dv plus the integral from 1 to sine of x of natural log of 1 plus 2v dv. Now I get to take the derivative. I want y prime. So in the first term, I'm going to replace v with cosine of x. So this is negative natural log of 1 plus 2 cosine of x, right? See? I replace v with cosine of x. But by the chain rule, I have to multiply by the derivative of cosine of x with respect to x plus natural log of 1 plus 2 sine x times the derivative of sine of x with respect to x. And if you don't mind, in the interest of room, I'm going to write sine of x prime. It's just another way to say the derivative of sine of x with respect to x. And so here, The derivative of cosine of x with respect to x is negative sine x. And a negative times a negative is a positive. So this is sine of x, natural log of 1 plus 2 cosine x, plus the derivative of sine x with respect to x is cosine x. So this is cosine x, natural log of 1 plus 2 sine of x. And that's going to do it for this video. This is a video on part 1 of the fundamental theorem of calculus, and we worked over 10 examples. Okay, thank you.